Hello, Professor. This is Aiden Carter and Grayson Weddle's assignment 2. Let's start with the bank account class. This class represents the bank account. It's initialized with initial balance, and the threading lock named sync is used to synchronize access to the bank account. This is important because in a multi-threaded environment, multiple threads might attempt to modify the account balance at the same time. Without the proper synchronization, this can lead to race conditions or corrupt the account balance. The balance is stored in the self balance right here, while self sync is a lock that ensures only one thread can modify the account at a time. The action queue stores transactions, both deposits and withdrawals, to ensure they're processed in order. Next is the deposit and withdrawal. These methods are responsible for adding deposits or withdrawals to the action queue. Each transaction is safely added to the queue by locking the sync object. Once the transaction is added, the update function is called to process the queue. The key part is, once the transaction is queued, update is responsible for updating the balance based on the transaction in the queue. The update function processes transactions one by one. It pops transactions from the queue and checks if applying the transaction will result in an overdraft. If that is true, it adds a transaction back to the queue, waiting for a valid balance. Otherwise, the balance is updated and the user is informed of a successful transaction. This mechanism prevents overdrafts by checking whether a withdrawal would bring the balance below zero. If it would, the transaction stays in the queue until a deposit replenishes the balance. This is crucial for handling situations where multiple threads may be trying to withdraw more than is available at the same time. Now, for the deposit and withdrawal threads. These classes are responsible for simulating multiple deposit and withdrawal operations. Each thread performs 5 transactions with a random delay between them, simulating real-world banking conditions where actions don't happen instantaneously. The run method here simulates transactions by calling the appropriate deposit or withdrawal function with a random time delay to mimic real-time operations. Here, in the main part of the program, we create a bank account with initial balance of $500. Then we start multiple deposit and withdrawal threads, each of which interacts with the same bank account simultaneously. By using the join method here, the main program waits until all threads have finished the transactions before printing the final account balance. So let's run it and see how it works. So as you can see, it goes through withdrawing, depositing. Anytime it hits zero, like here, it will not withdraw until a new deposit is made into the account. And as you can see here, it is able to withdraw multiple times because there's enough money in the account to be able to withdraw the amount of money without overdrafting. Thank you for your time, Professor. If you have any questions, please feel free to let me or Grayson know.